Okay, in this video, we're going to go through an example of converting a value in inches squared to a value in centimeters squared. I know a lot of you have trouble with unit conversion, and it gets even a little bit more complicated when we're dealing with units raised to a certain power. So hopefully this video will help you guys out. In the physical property analysis assignment, the inventor is going to tell you surface area in terms of inches squared, and the assignment asks you to convert to centimeters squared. So you'll follow a process similar to the one I'm going to show to you now. So this example is asking you to convert 5 inches squared to the equivalent amount of centimeters squared. So just like any unit conversion problem, we start with writing out our given, and then we're going to multiply it by some fraction, which we call a conversion factor, which will allow us to cancel out the unit we're given and to ultimately be left with the unit that we're looking for. So, weirdly enough, the way you do unit conversion problems when you're dealing with units raised to a certain power is you very briefly, for a moment of time, pretend like the power is not there. So I first want to just look at the equivalence between normal inches and normal centimeters, and that's on your formula sheet. And if you look on your formula sheet, you should see that 1 inch is equal to 2.54 inches is equal to 2.54 centimeters. That is the equivalence between inches and centimeters. So I'm going to put this equivalence into my conversion factor. So I have to write 2.54 centimeters over 1 inch. I don't want to write the other way around. I don't want to write 1 inch is equal to, I don't want to write 1 inch over 2.54 centimeters because I want my inches in the bottom to cancel out with my inches on the top over here. So I want 2.54 centimeters over 1 inch. Now I finally have to deal with the fact that this is inches squared and this is inches, so they can't cancel out directly right now. What I have to do is I have to raise this whole conversion factor that I just created to the power of 2. I can do that. I can raise this whole fraction to the power of 2, and all I have to do then is sort of distribute this exponent to everything within this conversion factor. So that means I distribute it to unit and number alike. So I distributed it to the centimeters to make that centimeter squared. I distributed it to the 2.54 to make that 2.54 squared. I'm going to distribute it to the inches here to make that inches squared. And I am going to distribute it to the 1 here to make that 1 squared. So now I have inches squared, which can cancel out with my inches squared. But the important thing here is now I'm no longer multiplying up here by 2.54. I'm now multiplying by 2.54 squared. All right, so now I have inches squared on in my denominator across from the inches squared in my numerator here. So now my inches squared can cancel, and I'll be left with centimeters squared, which is what I want. I just now have to do the math. So 5 times 2.54 squared, otherwise known as 2.54 times 2.54, is going to be 32.3 about. That's a rounded number. Divided by, 1 squared is just 1. So 5 inches squared is the same as 32.3 centimeters squared. And again, the way I found that was by setting my normal equivalence between inches and centimeters, and then using that conversion factor I squared the whole conversion factor because I knew I was dealing with a power of 2, and I distributed that square, that power of 2, to everything within my conversion factor, everything within this fraction, so that everything, unit and number within that fraction, is being raised to a power of 2.